Okay, so let's keep moving. So the new version of a bivariate figure that I want to teach you is when you have a nominal and a numeric dependent variable. Okay. So look at this table, for instance. This is a mean comparison table. Okay. And what I want to highlight here, and let's say that this is the hypothesis, that developed countries are more likely to respect human rights than their underdeveloped counterparts. We used this example in the past as well. So there are three things that I want to highlight here. The first one is that in this case, this is going to be the only case in which you're going to graph the whole table. Okay? So you're going to, because you need to, in this case, what you are using is the whole column, right? And you need to see if the mean score of Freedom House, for instance, changes as the values of your independent variable changes, okay? And the second thing that I want to highlight here is that you are focusing on the mean here, okay? So you need to learn how to estimate the mean rather than the count. But the third thing that is important here is that notice that the GDP is originally a numeric variable, but you're going to prepare an ordinal version of that GDP to make easier the analysis. Hold that idea in your mind because it's going to be useful and it's going to highlight in the future, okay? So you have these values, low, medium, high, high, and you have these different means, okay? Okay, now let's go to our data set. So we have, in this case, you need, again, to prepare your variables and so on and so forth. And the kind of hypothesis that we're going to see here is if there's a difference, basically, there's a difference between different genders in the income, the mean income that they have. Our hypothesis is that men tend to earn more than women, something that is kind of, how can I say it, like is something that we can expect to some extent, unfortunately. So what I want to highlight here is how to count and how to estimate the mean, okay? And we use here summarize instead of count. So you group by your independent variable and you say, okay, summarize and prepare the mean of the dependent variable family income, right? So you learned how to do this in the past. I'm just bringing these concepts that you learned in the past to this version of to these new challenges that you have. So you need to use what you learned in the past, okay? Something that is important that I have highlighted many times, when you use family income, you have a crazy value called 97. And 97 is when people don't want to say what is the income of their families. The problem with that variable is that it's an outlier that creates a huge right skew in your distribution of that variable, okay? Yep. And that skew is gonna distort the rest of the information of that variable. So delete the value 97. That's very important to do, okay? And this is what you have. When you use that kind of structure, that kind of command, you're gonna have the same that you have in the mean comparison table, right? Men, women, and you have the mean income. And notice that unfortunately, women earn less than men, okay? Let me go to R. Okay, so I need to move here from one to the other. So this is what I'm doing. The first thing that I did was to filter, later to count. And notice that it's the same, 7 and 5.9, okay? Okay, so now you need to learn how to create a nice bar graph, and it's basically the same. Oh my God. I don't know why, but I don't have the data frame here, but I have the data frame here. I'm gonna show you. It's basically the same. You create a new data frame and you create your independent variable, which is men, women, with the levels or categories, men and women. And you just create a new variable called mean income which has the mean income of men is 7 and women is 5.9. Okay? So you create that. And I'm gonna go directly to the nice version of the figure because I don't have time to lose with the bare bones. Okay? And this is the nice version of this. So you can represent here that men earn more than women in a correct way. The scale is fine and everything is fine. Okay? If you're gonna use the line graph, it's the same. You have mean, you have the group. You have here, I just want to show you more things that you can change with geom line and geom point. For instance, you can have points red, and you can have the line type could be dash, there are 2 dash, and so on and so forth. And that's all. So you have this version of the line graph. Okay? It's the same information, the scale is correct. Let me show you here. Bam. And let me show you here with the line graph. Okay. Lessons that we can learn from this. Use this part of the lecture if you want to know how to estimate summary statistics of a dependent variable. If you don't want to estimate the count, but you want to estimate the mean, the median, the standard deviation, the interquartile range, so on and so forth. So use it for that purpose. Okay? Let's move on. So imagine that your dependent variable now is ordinal. Okay? So we have, remember our table of partisanship and opinion and control. Imagine that people have 3 options: more control, no changes, and less control. So you have 3 variables. You can do a couple of things. You can do this, the basic idea or the takeaway of this is treat it as a nominal or as what we learn in the nominal version of the figure. And for instance, you can pick one or select one of the values of your dependent variable that you're going to be more interested. Okay? For instance, in this case, you want to imagine that your hypothesis is that Democrats tend to support more control. So you're going to focus on more control. And you're just going to graph this row. Or imagine that you have 5 categories of your ordinal variable. Because there are so many categories, maybe you lose a lot of information if you just go for one row. So what you can do here is to collapse those categories into fewer categories. And actually, if you can transform that variable into a nominal version, like or an ordinal with 2 or 3 levels, that's great. And focus on one of those categories of your ordinal dependent variable. Okay? I'm not gonna go step by step because it's basically the same that we learned. We're gonna use the count and we're gonna focus on one category. Okay? You can go to the replication materials and you're gonna find how I did it with the ordinal, with a nominal ordinal kind of graph. Okay? And I created these two, the bar graph and the line graph. I wanted to examine if there's a difference between men and women in terms of access to higher education. And I said my hypothesis that men tend to have more access to higher education than women. And what I did here is to focus only on postgraduate students, okay? And of course, men to have more access to postgraduate education than women, okay? Not of course, but it's what happened here. And you can do that, or you can transform the variable education, which is an ordinal variable that goes from 1 to 6, and you can create just 2 categories, higher, equal or higher than 4-year college, or lower than 4-year college. Okay? That's what I did. Okay. And now let's go again to multivariate kind of figures, and we're gonna learn what to do with numeric versions of your independent variable. This is the hardest type of figure that I'm gonna teach you today. It's very hard because there's gonna be a change in many things, okay? But the first thing that I want to highlight here is that you need to know very well your independent variable. Because what you are doing, similar in the past, so if you have like a categorical independent variable with two levels, low and high, well, you need to count for low how many support Medicare, for instance, and for high how many support universal provision of Medicare, right? But what do you do with a numeric variable? If you have a ratio level in independent variable, so you have infinite number of values of that independent variable, right? If you have an interval variable which is more manageable, for instance, with 13 levels, you can try to find 3 values of that independent variable that are meaningful in the distribution of that variable. For instance, in this case, we're going to use family income. Family income is actually an interval variable, right? And it's a little bit more easy to manage, and I want to introduce these concepts with that variable, okay? So what I'm going to suggest you to do here is use the mean or the median. Usually the mean is better, and a higher level value and a lower level value. But which values could be the minimum value or the maximum value? But the problem with that minimum and maximum is that very few data is going to be in the minimum and maximum. Okay, you want to focus on what is the most likely distribution of this data. So you can use, for instance, the interquartile range, because remember that the interquartile range covers the 75% of all the data. Okay, so the first quartile here is 4, and the third quartile here is 9. So you can select 4, 6, that is your median or mean, is almost the same, and the third quartile, 9. Okay. You can also use the standard deviation. For instance, if you're preparing a ratio level, you can use the mean and maybe 2 standards deviation higher and 2 standards deviation lower. Something like that can be useful for you. So in this case, you're just going to use 4, 6, and 9. Okay? Okay, so in this case, when you count, you're going to use first your control variable. I'm sorry, I use my independent variable, family income, later your control variable, approval, and finally your dependent variable, Medicare. Okay? And notice that this is the first time I created an object, in this case X, to assign the results of that estimation, because the table is going to be so large. It's going to be so long, actually. It's very long. So for that reason, to explore and to see the table, you need to create that object, and you can use this function view. Let's go here just to show you. So this is here. It's one, numeric, nominal. Okay. So the first step is this one. You explore your data, later you count, and later you view. Use view to open the table, or go here directly and open X. Okay. Okay. So once you are there, start counting. So remember that your independent variable is 4. Your control variable, or the other variable that you're interested in, is approval, right? And the other one is support to Medicare. Okay, so you're gonna have here, you're gonna go to the row 4, disapproved support, which is in this case 3,000. Okay, this is the first one that you're interested in. 4. Later go to those who approve Trump and who support Medicare. Okay, in this case is 1,000. Okay, so you get it. So what you need to do here is to basically find those rows that are meaningful for you. But your independent variable is going to be here 4. Later you need to go to 6, because remember that we selected 4, 6, and 9 as the levels or the values of your independent variable that are meaningful to see that distribution. To count the support for Medicare. Okay.
Okay, so just to reinforce a little bit more this idea of counting in this case, so remember you need to go to the rows rows that are relevant for you. And in this case, pay attention to the levels of the independent variable that you selected as relevant. In this case, the mean. In this case, the mean is equal to the median in family income, and a value lower than the mean, that in this case is 4, which is the first quarter, and a value higher than the mean, which in this case is 9, which is the third quarter, right? So the whole range of the inner quarter range of the distribution of this data is in that range of values from 4 to 9. So what you do is that you go to 4, and the values of the independent control variable that are relevant for you, which is approval, first disapprove, and later approve, and the count of people who support Medicare, as in this case. So it's 4, disapprove, support, and you count those numbers and write down those numbers somewhere, okay? Later you go to 4, approve, support. Later you do the same for 6, and let me move this here. Later you do the same for 6, and later you do the same for 9, okay? Okay, and the main difference here is that I'm gonna teach you how to use a table instead of a data frame. It seems that the data frame has problems when you have more than one numeric variable. So in that case, it's better to use a table. And this is also a concept that we learned in the introduction to R, in the first lectures, probably the first one or the second one. When we studied this idea of how do you introduce data into R. So remember that in this case, this table is a space separated data, okay? So you are separating data, and you write the lines, and each line is a row, and you separate the columns by a space, okay? Notice that you write the name of the variables here. For that reason, I wrote these names of the variables in green because they represent the variable actually. So in this case, approval, income, and count, and you write the values. So you do the same that you did here. So disapprove, value 4, and the number of people supporting Medicare, which is 30,000. In this case, is the same. Later you write disapprove 6, disapprove 9, approve 4, approve 6, approve 9. Okay. And this is another way to present to create this information that's going to be a graph. Okay. And here, the most important thing that you need to keep in mind in terms of syntax is to write this header true in order to create these variables. Okay. Okay. Later, you create a bar graph, as we have learned how to do it. Is the same. You write here what is your independent variable is X, your dependent variable is Y, and your control variable is approval. And the rest of the code is the same. So let's do it in R. So we have here, so we create the table, and later you create the graph. That's your graph. Okay. This is the bar graph. The bar graph is nice in terms of aesthetics, but it has a problem. As you can see here, it's not very, I don't know how to say it, suitable for plotting this kind of information. It seems kind of ugly, and the information is to some extent distorted. So you cannot, it's not the best way to present this kind of information with the x-axis as a numeric variable. It works so much better here, the line graph. So the code is basically the same as we have seen. You use group with your control variable, which is in this case is approval. Okay. And let's run this. Time. Okay, and this is the graph that you have. It's a beautiful graph. As you can see, I really like it. And it's more, I don't know, it works so much better with this kind of information. When you want to represent this numeric variable in the x-axis, it's so much better. It works so much better because you are not distorting anything, okay? And this is the distribution. It's an amazing way to present it. And you have the same here. You have your, okay? That's the multivariate with your independent variable as numeric. What lessons can you learn from this? The most important is how to deal with a numeric variable, independent variable, okay? So you can use it if you want to prepare a bivariate figure, and your independent variable is numeric. Use this information that you learned here. The takeaway of this multivariate figure as well is that try to select 3 values of the independent variable that are meaningful for the distribution of the variable and count. And interval levels are easier to manage than ratio levels. When you have the ratio level, good idea is to create a meaningful ordinal categories, such as in the case of the GDP. So remember here, the GDP is actually a ratio level variable. And what you did here is to prepare, or what Pollock did here is to prepare these 4 categories, like a low GDP, medium high, medium low, high, okay? That's a good strategy to handle with that complexity of 2 numeric variables. If you don't want to do it, if you want to create an actual figure for 2 numeric variables, the best way to do this is a scatter plot. So scatter plot is a very simple structure. So you can see here, and you use in your x, you write one of the, you just write x and y for your independent and dependent variables, and you use the geom point. For this example, I used Gapminder that is attached to the DS Labs package, and I delete all missing values and created a new version of the dataset, which is called GM, okay? So let's try that final code. So you have something like this. One sec. I think I have to recreate everything. Okay. Now, this is your scatter plot. Okay. This is a nice scatter plot in which you have in the x-axis infant mortality, and you expect that higher levels of infant mortality will be related with lower levels of life expectancy. So this is correct according to your hypothesis. Okay? So you can make this this figure even better. And in order to do that, you play or you change the shape, or especially the shape and the, let's say that, the intensity of the color of the geom points, and that's basically what you do. And the other thing that I change here is that the color of each point will be determined by continent. So in this case, I use continent as a kind of control variable. It would be better if you have here in your control variable only 2 values, so you can see the contrast so much better. For instance, if you select red and blue or something like that, you can see the contrast in a better way, okay? And this is the nicer version of the scatter plot. So you can see here how the effect of higher levels of rates of infant mortality in countries in Africa, is stronger in reducing the life expectancy than in countries, for instance, in Asia, actually. So you can see that, and this is a good way to present this is actually a multivariate figure because you are controlling by the color of the geom points. Okay, that's all, guys. Thank you so much for everything. This is the final lecture, and I hope this works for you. And if you have questions, please write me those questions in the discussion board. Thank you so much. Bye.